Yeah, I did. I really did fall asleep. Okay, this is part 2. Part 2, we have to deal with the tangent to a circle. Remember, a tangent line is a line that just grazes the circle. It's only going to touch the circle at a single point called the point of tangency. Other than the fact that a tangent line only touches one point on the circle, the key property of a tangent line is that the tangent line will always be perpendicular to the radius. Let me say that again in case you were spacing out. Okay, is everybody listening? The radius and the tangent line are always perpendicular. Okay, 90 degrees. So remember the warm-up when we talked about opposite and reciprocal? That's where this is going to come in. When things are perpendicular, their slopes will be opposite and reciprocal. All right, anyways, let's watch it unfold. Okay? So, what you have to learn from part 2 is just this. How to write the equation of a line that's tangent to a circle. So, here I've given you the equation of the circle, and I've given you the point of tangency. All right? So let's, oh, you know what? Okay, if I want to find the equation of the line that's tangent to the circle at the point -6, -3, here's the thing I need to do first. So first picture it. So you've got this point -6, -3. This particular one, the center is at 0. You could tell because it's just x squared and y squared, so you knew it was at 0. So you could basically draw this type of a picture. Now, so the tangent line is this red line. We're trying to find the equation of this red line. We really need the slope in order to write the equation. So look at this. What we're going to wind up starting with is looking at the radius of the circle, because we can easily find the slope of that. So how would I find the slope of this radius, you guys? Well, what is slope? What's the first thing you learned about slope?
Rise over run.
Rise over run. Isn't that the first thing you guys learned about slope? So look at this radius. Let's just do rise over run. Okay, so as I do that, I heard DeMarco over there nailing it. Rise over run. The rise here is 3 if I went all the way up. Okay, and the run is -6. Right? It's like up 3, left 6. So if I do rise over run, that means the slope is going to be 3 over -6. That's -1/2. Okay?
So you can't have a negative slope, right?
Oh yeah. See how the line is going downhill? It's going to be, you know, it's going to be negative because of the way it's downhill.
Would the slope also be negative if it was like in like the quadrant below it on the left side, like going down like that? Yeah.
No, this would be a positive slope.
Okay, so it's
Because from left to right, this would be uphill, so that would be a positive slope. This would be a negative slope. That would be a positive slope. Got it? Wait, now I got to erase that stuff. Okay, one thing before I go on with the problem. I don't want you to have to draw these pictures in order to do these problems. This slope of -1/2. Who can tell me how I could have gotten that slope without drawing any picture, without actually drawing a rise and a run?
3 over -6.
Okay? See, we have the 3 and the -6. Okay? All we really had to do was, because it was 0, 0 anyway. I lost my pen. Oh, there it is.
Yeah, that only works for 0, 0.
Yeah, this is only going to work when it's 0, 0, but that's the most common thing that we're going to be working with for this type of a problem. So just understand this slope. We could just do it by doing y over x. As long as we're at 0, 0, we could just simply do y over x. So you wouldn't have to do the whole picture or anything. Okay? So now, we found the slope of the radius. Okay? So fine, I have the slope of the radius. The radius slope is -1/2. But that's not what I really needed. I need the slope of the tangent line. Who can tell me what that is?
Opposite of that.
Somebody said 2. Okay? Where are we getting that from? How do we know that the slope of the tangent? Tiger. Remember that the radius and the tangent are perpendicular. Okay? So their slopes will be opposite and reciprocal. So if I know that the radius is slope -1/2, I know the tangent line is going to have slope 2 because I'm doing opposite and reciprocal. All right, let me flip back to the lesson. Okay, so coming back to the way it is on your paper. So again, the slope of the radius, okay, so we had -6, 3. All right, so this was my point of tangency, right?
Yeah.
All right, so even without drawing the circle, you can just picture that that was our radius. So the slope of the radius, we could have just done 3 over -6 and gotten -1/2. But then the slope of the tangent line, that's what you're going to find next, that was going to be 2. All right, opposite and reciprocal. Okay. So now it's just like the warm-up that we did. If I want to find the equation of the tangent, I can just use y equals mx plus b to find b, just like the first problem we did in the warm-up. So if I need a y value, I'm going to use this one, the 3. Let me zoom in a little bit more. Okay, if I want a y value, I will use this 3. So y equals mx plus b becomes 3 equals. Now remember the slope, we just found it. That was 2. What's the x value? -6. So I have everything but b. So I should be able to find b. All right, Blaine? I feel like you're not paying attention. So that's going to be -12 plus b. And then I would add 12 to both sides. So that gives me 15. Okay, so my b value is 15. So that means the equation, all right, now that I have the slope and the y-intercept, I can write the equation. So that should be y is equal to 2x plus 15. Okay? And that is what I need you to learn from this part of the lesson, from part 2, how to do what I just did.